Hello, everyone, and welcome to the Future of Space. I'm your host, Daniel Fox. Our guest today is Dr. Joel Parker. Dr. Joel is an astrophysicist, planetary scientist, and a director at the Southwest Research Institute. He's the Deputy Principal Investigator for the ALICE ultraviolet spectrograph instrument on the Rosetta mission, a co-investigator on the New Horizons mission to Pluto, and has worked at NASA's Goddard Spaceflight Center studying hot, massive stars in neighboring galaxies. Joel, welcome to the Future Space.
Thank you very much, Daniel.
Well, I'm really glad that we met at Starmus, which was an amazing gathering of some of the brightest minds, and you were there, so you're one of those brightest minds. But it was really fun to hear. I think that in this world of doom and gloom, it's always I think refreshing to hear really smart people coming to the table and trying to find solutions and moving forward. So I'm
Absolutely.
grateful for.
Yeah, it was an impressive festival to be at, and I feel incredibly lucky to even have my name somewhere on the same page with Nobel Prize winners and astronauts and people who've been explorers all their life. So yeah, and of course the rock stars too.
Yes, because you're a musician, and we're gonna get to that.
I am.
You're a
Okay.
musician. You love music, and it's funny because later today I'm interviewing Scott Hubbard, who also music, and
Right.
Chris
Yes.
Hadfield, also a musician. So
I keep saying at Starmus we should have a non-pro concert sometime of all the scientists who are really quite good musicians.
absolutely, I'm pretty sure that Chris and Scott would back you up on this. So let's email Brian. Um,
Yes.
Joe, before we carry on the conversation, I always start the same question. The goal of these questions is just to bring a little bit of context is, and I did the same thing with nature for 4 years. I interviewed leaders and I asked similar questions. But we think as space as a destination, right? A place that is above us or beyond us or outside. But with these questions that I ask, I try to change the destination to a set of values, a set of ideas, how they can resonate to the general audience. So for you, what would be 3 words that capture the essence of space?
Well, I would have to say this space is everything and more. And that fits in 3 words. Um, and by that I mean, it's space, we think of as space as everything we can think of, but it is not only that, it's more than we can actually currently imagine. And that's the great thing. We have this idea of what space is, whether you look at it from a human exploration perspective or a understanding how the universe works or the origins of life or planets and things like that. Um, and we are actually limited by our imagination right now of what we think. Um, but the great thing about science is the surprises, the things we did not think about, the things we did not imagine. We get some data that make us go, something strange, not expected. And and that leads us to things that we hadn't considered or hadn't imagined, and it makes space in the universe that much bigger for us now because uh, it is now everything we imagined and more than we previously imagined. Um, One of my favorite comments that I tell people is that, especially when they say, scientists are so smart, they know everything. It's like there is infinitely more that I don't know than I know. And that's both humbling and exciting because it means that you could do science for a very, very long time, and still discover new things. And also, I like to say that uh, that means ignorance is okay. There, there are things that we don't know. I think it was Richard Feynman who said something about, there's no shame in not knowing things, and the essence of learning is not knowing. So that's a long explanation for 3 words.
No, but it's, I mean, that's what it is. And it reminded me of when you were talking about not knowing is permissible. The like in Asian philosophies, you can never be a master, right? Every time you think that you're a master, you've actually failed in understanding what it is, because you never reach this place where everything is known. There's always, for every door that you open, there's a new door that appears in front of you, right?
Absolutely. Again, another cliche that I like is the more you know, the more you realize how little you know.
Now, did you um, when you started in your career, or even as a young student, looking into your interest in at the beginning of your career, did you think that you would get to a point where you are today with the tools available and these breakthrough understanding of the universe now, available to us, and with also kind of a new field ahead that is just giving us even more questions? Did you think that we would be here today?
Not even close. Um, when I was very young, I knew there were astronomers, but I really never thought of it as like a job, like something you do. Astronomers were just these people who went on mountaintops and looked through telescopes. Um, I liked I liked puzzles, I liked math, and so that kind of led me in the direction of science. And I figured I liked science because um, it was uh, puzzles and trying to figure things out, and trying to figure out what is not known, and then asking for grants to figure out what you do. So it was not really something that was in my mind. And even as I um, became an astronomer, got my PhD, and was doing research, um, you know, the Hubble Space Telescope was just coming online, and that was opening up whole new worlds. And when I was studying massive stars, which I don't do so much anymore, I'm doing more planetary work now, but when I was studying massive stars and nearby galaxies, one of the early Hubble images was of the cluster of stars in the Magellanic Clouds that I studied for my thesis. And that was really exciting. So I worked on Hubble data and other space telescope data like the International Ultraviolet Explorer and others for a while. And there was always just coming online new ideas from people who this is what they did, was come up with new instruments, new cameras, new ways of observing things at different wavelengths that were just incredibly exciting. So you go to an astronomy meeting and you hear these people talk. It's like, oh, this is great. I didn't know that they were developing this, and I could do this and that and the other. So even going through my professional career, um, there's there have been continuous surprises of both new tools, but also new ideas. Sometimes I try to come up with the new ideas, but very often other people are, that I can then go, oh, that's great. I can apply this idea or this method of analysis or process to something I do. So I love that whole kind of community interaction part in astronomy. and also that astronomy is truly an international field. And it's small enough that you get to meet and know the people who do all this great work on all the papers that you've read. So yes, it's been just one surprise after another, and I've loved it.
And I will circle back on these ideas, but I think that this is a great tie into the second question. Right? We know that when we talk about space, we're quick to say there's a science story of space, there's a technology story of space, we just saw China landing on the moon, the geopolitics law, right? Who's gonna, like, how is that migration is gonna happen? But beyond that, what would be for you the human story of going to space?
I, in a lot of ways, for me, the human story of going to space, and also just, in going to space, I'm using a broad term of both the human exploration of space, but also the general exploration of space and the universe, is a lot of it is kind of finding ourselves. So the discovery of our origins, and this is a question that goes back millennia, right? How did we get here? What brought us here? Do we have some meaning here? Is it is there a creator of the universe, or does the universe not really care what we do? There are a lot of these questions that are answerable through exploration in scientific study, such as the origin of life. We can study that. The origin of our solar system and the planets in it. We can study that. We can figure out how this solar system formed 4.5 billion years ago, or at least a pretty good idea. And it's not only questions that go back millennia, but it's even questions that go back to us as 2-year-olds. It's like you get to continuously be the 2-year-old who keeps asking why, why, why. And that's, to get to do that, to always get to ask why and then try to find out why, I think is really important, and it feeds a certain human need. And in another way, I could say that our world, all of us humans here together, we are kind of arguably the 2-year-old equivalent in the universe as a civilization, depending on what you believe for different values of the Drake equation about how many civilizations there might be in the universe. If civilizations are long-lived, then, on average, we are probably a very young civilization. If civilizations are able to kind of get over some of these steps of, risk to themselves, like you always have to watch over a 2-year-old not to play with something sharp. We're not aware of anyone looking over us, that we don't play with our climate or our weapons in a way that might harm us. If on average civilizations can get over that kind of 2-year-old be careful hump, then there are probably many, many very long-lived civilizations, much, much millions, perhaps even billions years older than us. So we are young, and kids asking questions is what they're supposed to do. So I really think that the human story of going to space is finding ourselves and finding our origins and our place here.
It's I think that my mother would I have some comments about the why. I was the kid that was just like always why, and it's like it was just this constant. Not that like I wanted to be proven anything. It was just I wanted to understand the connection between these dots and the rationale behind. And often in conversations, I find myself I love to be the devil's advocate, not because I don't agree with people. I like to not agree with them, but I want to hear the rationale to support their
Yes.
someone for me that just says I don't like this. Well, why? Well, because I don't like it. Well, I'm sorry, but you don't get my respect there. But if you tell me I don't like this because of this and because of that, then I agree that it might not be, for everyone, but there's a thought process behind it. Then I'm like, you know what? You got my respect. And so for me, the why has always been a way to give credibility to my environment, right?
I absolutely agree, and I like that perspective in two ways. One is um, that asking why uh, can help you understand more things, um, and it could help you change your mind about something that you assume if you disagree with someone and you keep asking why, if they're able to give you good reasons why that you haven't considered, in an ideal world, that might change your mind and make you see things differently. And, I think that's the strength of this, of the idealization of the scientific method, is that we are, as part of our job, we are asking not only the universe, but each other, why? Justify this. How did you get to that answer? Explain to me, show your analysis, show the math. Um, and I really appreciate that questioning is an inherent part of the process. Now we're all humans. We all have our biases, and some of us don't like being challenged on our assumptions and what we think is true. So on a personal, person by person human basis, there will be biases. But I'm a long-term optimist that over the arc of time, that those small individual biases get washed out by this constant questioning by many people with different ideals, and the arc of science tends toward more understanding of the truth or how things really are. Um, so, yeah, that's I I try not to be annoyed if I get asked why by a 2-year-old too much, and that's, you will find a lot of scientists who give public talks. They say the hardest questions come from the youngest kids.
Well, they come from a different perspective. They don't have, I mean, they look into the simplicity of these statements. Uh, but yeah, I think the why, like, I don't think that there are any other species on the planet that stops and asks these questions, right? I mean, I don't think that, no.
I haven't asked a dolphin,
But
or an
I would still
octopus
be
yet, so
surprised that they would be like, why? Why is it? But that's
right.
the beauty of figuring out and developing the empathy, understanding that there's a story, and I think that we've been good, generally speaking, when it comes to science, to asking why. But when it comes to our humanity, I think that we have a tendency to avoid the why and go back to a place of thinking that everything is rational and the why recently wrote about we deny a aspect in ourselves, and it's that same part of nature that we deny, right? The chaotic, the messiness, the unfairness of nature, the biology of nature, the strong and the weak. It's that same aspect of ourselves that we don't want to dismiss, that we want to dismiss, we want to put aside, right?
Absolutely, absolutely. And that, well, that's one of the reasons I went into studying stars and planets rather than people. You know, a favorite quote of mine that I've heard from others is, you know, space missions are easy, people are hard. and and that does reflect back into how people view science. Um, Sometimes science is viewed, and sometimes it's presented as this is the absolute truth. We know it 100%. And in reality, a lot of the science work, and if you go into the papers, it's, well, we know this to a certain level of certainty. And yes, there could be a scientific revolution which will totally overturn all of our previous concepts, but that takes some profound, fundamental work, research, a lot of people asking why, evidence-based work to make that happen. And many times that's not even an overturning of ideas, but a significant refinement. So, you know, relativity did not overturn Newtonian mechanics. It just refined it in cases where there's, you know, high speed, high level of gravity, high masses, things like that. We still use Newtonian mechanics all the time for what we do every day, so it wasn't overturned. So when science is then goes into the public or political sphere, people want absolute certainty, and that's hard because a lot of scientists know this is the best we know. There may be aspects that are wrong, but right now, this is the best we know. So we might as well act on the best that we know. But it doesn't mean that something might be different later.
And I think that often we mistake the why to what does it mean to others, right? We give the information and why, and often like for people and I think that's part of the reason why I love the work that I do, is trying to find that thread that connects the why to the personal experience. Because most of the people, like even for space or even for the environment, like why does it matter to me what happens some halfway across the world? Why does the technology matters to me if it's going to make me lose my job? Like so the why is extremely important, but the humanity is, I think, more connected into how does it connect and relate to an individual so that these two can coexist, right?
Absolutely. And maybe overgeneralizing here, but I think a lot of the progress in science has been showing increased level of interconnectivity, interdependence among systems, humans, in the environment, you know, even quantum mechanics, spooky action at a distance or what have you. There's more and more that is connected. And I think part of it is we're discovering that because both our tools become more advanced and enable us to see and measure more of these connections, but also our broader understanding of science in the given fields has, you know, slowly evolved over time, adding on more layers of complexity to the basic underlying knowledge of, you know, how this works or how that works. And as you get on those additional layers of complexity, you have to start pulling in other considerations, other aspects that you hadn't seen before, which shows more interconnectedness. So, um, I'm not a climate scientist, but I can imagine that that is how climate science has evolved from kind of very basic, simplistic models of climate and weather for wind patterns and things like that, but then understanding chaotic systems and understanding more details about radiative transfer and things that hadn't been considered before about how the oceans interact with the atmosphere. And each of those steps brings in another layer of both complexity and interdependency. So, um, I think people are getting more of a intrinsic gut feel that what happens on the other side of the world could actually affect here and affect me. And technology has probably enhanced that to an extreme degree through social media and stuff like that, where now what someone says in New Zealand, I may take very personally, even though I've never met them. And, 50 years ago, what they thought wouldn't have mattered.
Yeah, I think with the rise of the scientific revolution or awareness, we went on a quest of categorizing everything and dividing everything. We look at species and they have their own name, and we look at everything and as if like we went through this period of seeing the world in tiny little vacuums. Everything exists disconnected from everything else. And now we're starting to understand it's not nurture and nature. It's always both, right? They always, and they pull from it. And you have an entire spectrum between the two, and you can find different people or different things at different places. But there are two questions that I want to ask you. One is, one of my beliefs is I've always thought that the nature of the universe, right, beyond the planet, is no different than the nature on Earth. Nature would not do something unique to the planet. Whatever dynamics, whatever chaos, whatever principles of life that we find on Earth, whatever observations will be found in the universe, but of a different scale. So that's one thing that I believe. The other thing is life. When we look for life in the universe, it's not just looking for the ingredients for life, but looking for this situation where these ingredients are conflicted with each other. Like if we look at one of the metaphors that I use, you can have on your counter flour, water, and air to make bread, right? You can have all these ingredients for bread, and you can leave it on the counter for thousands of years. Nothing is gonna happen. Bread is not gonna. What needs to happen for bread is you need these ingredients to come in conflict with each other, interact, and then after that you have to put into fire, and then it creates the bread. So life in the universe and the planet itself, it's not just the ingredients, it's the fact that these ingredients have been mixed by the Jupiter, the moon, these accidents that created, kind of where we are today. So these two questions, the nature of the universe and the ingredients for life.
Oh, just those two questions.
Just those two.
So a basic assumption in astronomy and astrophysics studying the universe is that the laws of physics are the same elsewhere as they are here on Earth. And there are ways we can test that by looking at details of the light that we get from distant quasars and things like that. And finer and finer tests with general relativity and things like that. And for the most part, that is turning out to be correct, that we see that the laws of physics pretty much are the same everywhere. Every now and then, there will be some surprise that will lead us to an understanding of something that might be different because, we don't live near a black hole and we haven't really studied what the physics is like around there. There will be some surprises, again, that will be perhaps refinements. Dark matter and dark energy, those are kind of bookmarks for we don't know. And we are looking for what the forces or what the particles might be that fill in those unknown bookmarks right now. That may lead to a revolution and may lead to some understanding of there is something in very early times in the universe, very distant areas where maybe there is a slight addition or change to the laws of physics as we assume them here. So, that question of what is here versus far away, we tend to think it's the same. And again, the progress of science has always been removing us further and further from a special place, from the center of the universe. And a lot of times in scientific analysis, you will have scientists question each other saying, but your result really depends on special conditions. And you can't always guarantee that those special conditions existed for that. So a lot of the times our assumptions in science have to fit into the concept of does it or does it not require some special conditions, some fine tuning to make it work. So we've gone from the center of the universe and from the center of the solar system to just a star on the outskirts of a galaxy like many, many other galaxies, and a cluster of galaxies like many, many other clusters of galaxies. That bothers some people because we want to feel special. But feeling special, I think, feeds into the question of life, your second question there. If all the ingredients are out there, but they haven't been brought in conflict with each other enough, if we are in fact the only life in the universe, we are incredibly special no matter where we are in the universe. And this is still a fundamental question. Are we alone? And there are many reasons we ask that question. Curiosity, fear of being alone, fear of messing ourselves up and killing ourselves off when we're the only evidence of life in the universe. Lots of different reasons. But if I were a gambling man, I would say we are not alone. That somehow those ingredients of flour and water and heat and everything else to make bread or a cake have been brought together in conflict many, 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 many times in this very vast universe, and vast in space and time. You talk about, you said in 1,000 years, those ingredients sitting on your counter won't make bread. But we are talking thousands of thousands of thousands of years, billions of years. And over that time, those ingredients have a very high possibility of occasionally coming together in acceptably close enough proportions. It may not be the best bread in the world, but it's bread, And I think, although it's more complex, the elements of life, we know the elements, the ingredients are out there. We have seen them everywhere we look, on comets, on other planets, on moons, floating in gas clouds in outer space. Those ingredients, and very complex ingredients, are out there. So it is that, how often do they have a chance to mix together in not even the right conditions, but just the good enough conditions to make life? So I'm not an astrobiologist, but I hang out with astrobiologists, and I would put my money on we are not alone.
I do believe.
But if we're not alone,
No, I do believe that we're not alone. Just because I think that the nature of life exists in a lot, right? But there's a spectrum of that complexity of life. The life can exist on the planet for hundreds of millions of years, and had it not been for that giant rock falling from the sky, the dinosaurs would most likely still be around today, right? So the difference.
I'd be a T-Rex, and you'd be some other dinosaur having this conversation.
And for that reason, we are, as we know, the first species in 3.6 billion years who now has the capacity to take life beyond and to give. I mean, why would something grow in complexity for billions of years to remain on a tiny speck in a ginormous universe? It would be a waste of investment, right? There would be no point to it. It would be kind of a.
Well, it leads to. I'm full of all my favorite quotes, but why is space so empty? That seems like a waste of space.
Wouldn't someone say the same thing about Earth? If you ask someone to come down and make a quick assessment of what is important on Earth, right? They would say, well, you have the Earth, you have the ground, the rocks, you have the ocean, and it would stop there, not understanding that the invisible, the air, is the most important part. Is the source of air, this is a source of breathing oxygen, but it's also how the cross-pollination of plants and everything, right? So when you walk on a lava field in Hawaii and you have a desolate land of burned rocks, scorched everything, right? No man's land. And suddenly you have this tiny sprout of life that comes out of nowhere.
Isn't that amazing?
But so for me, this is the same thing in the universe, right? What we think is invisible is not invisible. Is filled with things that we don't see. And then you have these seeds, and these seeds are just comets, asteroid, but the medium that life can travel on, and then it comes in conflict with anywhere. The same way that, like, on a lava field, it's not because you have one sprout over there that's the only one. Like, if you had the magical lens, you would see that the air is filled with trillions and trillions of seeds. But this one was successful.
Yep.
So life statistics, and that's why the scale of the universe is so big. Is because nature. This is my thing. I don't think that nature is efficient in the way that it does things. That's why it needs scale and time. We have taken the randomness and the inefficiency of nature, and we've been able to create a certain stability over it. And now we're capable of engineering our way forward and accelerating a process that usually takes hundreds and thousands of years of adaptation. It's just that it's also more challenging in dealing with because we have to constantly react and act in ways that we have not caught up with. So it's the double-edged sword, the blessing and the curse of, here we have awareness, amazing, but here you have pain. You can't dissociate the two, right?
No, absolutely. And it is a very much double-edged sword. You see that in human interactions, unintended consequences of well-meaning actions. You see it in science of unintended usage of things that you thought would just further knowledge or save the world, but it's used for purposes you never imagined. Um, it's very true, and you know, the universe kind of is agnostic towards that. In that, like you said, it just it can rely on large numbers over long distances of time or long periods of time to let things happen. And there's not a moral, it's good or it's bad, just things happen. Life can be created. A planet can be hit by a rogue asteroid. There was no meaning behind it, so but they happen. So we need to be prepared to deflect an asteroid that we think it's going to come towards Earth. Things like that. Or become a interplanetary species to protect ourselves if there is a disaster like that. I'm not a fan of we're ruining the Earth, so let's just move to another planet. No. Moving to another planet may be a safety backup, but we still want to keep what we have to at least be able to continue our human exploration.
It's the principles of evolutions are unfortunately messy because the incentive for adaptation involve stress and tension, right? Every single species will consume and procreate until they find, I mean, this is great migrations. Every animal, they will eat everything and then they have to figure out how to get to the next place. If you have, a family, you have your children, if you kept all your children under the same roof generation after generation, I can guarantee you there would be a lot of conflict and violence, under that same roof. And you look at Europe where it was in the 1500s and 1600s, the incentives that were there for people to risk everything for a new start. Europe was a total disaster, right? Every single tree had been cut to construct boats, ships. The Thames River was so polluted, they had to close down the parliament, the stench. The aristocrats had everything under control. There was nowhere for a lot of people to go. So they were willing to risk getting onto a ship in conditions, horrid conditions, all for the promise of something better, right? So, and that tension created two incentives. It gave some the desire to go beyond and because they saw themselves, maybe over there's an opportunity. And it offered the people that stayed behind the necessity to fix and where the people went also became part of the solution. You look at the impact of America, and yes, America is still and has made a lot of errors, but these values on which America was funded on have spread all over the world and have elevated Europe and all these different places. So space, these new frontiers, always, it's not one at the expense of the other, but it's one with the other for the benefit of everything.
And there's just that. I feel there's a human drive to explore, and it's not for everyone. Some people are homebodies and they're happy to be where they are and they don't want to explore. But more often than not, again, it's back to the 2-year-old. Out in a field, they're going to go start looking around and where are the little bugs and what's over that hill and where did that cow go, and there's exploring is an innate part of curiosity, which I think is an innate part of being human.
Yeah, absolutely, Joel. I want to be, I want to be mindful. I want to be mindful of your time. I love conversations because like when it gets to a point where you have to put a stop because you it's just and it's not like confirming or answering each other's questions. It's just that these are great conversations where you have a seat and
Right,
then it makes you
right,
think of
right.
something else, and then but in that and being mindful of your time, what would be Joel's three words of wisdom?
Uh, I would say, based on everything that we've talked about, my three words would be uh, discover the questions. Um, you know, a fun part of being human and a fun part of science is not just finding the answers, although that's great, but also to find the questions. I mean, how great of a job is it that you get paid not only to answer questions, but to figure out what questions there are to answer? Um, and in some ways, you could argue that it's the discovery of the questions that is almost more important than answering them, and maybe more important than answering them, because discovering questions means you're discovering what you don't know. You go beyond your sphere of knowledge, and that's a growth and an exploration that I think um, is just an essential part of life, and it's fun.
And that's the big difference from our ancestry of survival, where all your time and energy is spent into fulfilling the needs, the physical needs, roof over your head, safety, feeding, and then, but technology and tools have allowed us to open the field of questions and continuously move to new areas of questions right now, with quantum mechanics and all these questions that before we didn't. It's not that we didn't have the answers, we didn't have those questions because we couldn't think about those. Now we can start asking these questions. And I remember flying over, and we'll be short and I can let you go. I was flying over New York, looking out the window, Manhattan at night, skyscrapers, lights everywhere, and taking for granted that I'm in a machine flying in a place where I can eat, sleep, go to the bathroom, and I'm taking a photo on a device that it can also connects me to someone halfway across the world, and I can do my banking and I can do all that kind of stuff. For the Italian explorer who'd landed less than 300 years ago, where this place was just a forest, and he'd come on a wooden boat, even if I tried to tell him an idea of what was the future, I would be burned to the stick because of witchery or because of like it's so impossible for them to think that this is possible. And that principle of not being able to see the future is no different today, right? There's a future ahead of us that we're incapable of imagining because it's just beyond what we can understand. And that must be
That's
always fascinating for you.
it is, and I feel incredibly lucky individually, um, that I have a life where I am not in base survival mode as many people are in the world right now. So I feel very lucky that I have the chance where I can afford the time and the energy to ask questions and why. And I feel very lucky that humans, um, on the whole, find value in supporting those who ask questions why. Um, so it is very special that we are at a time in our evolution where we have the intellectual capability and the time to ask why, and to imagine what the future might be like. And just along the line of what you said, one of the things I like to say is, imagine how much has changed over the past 100 years in any field you want to pick, in physics, biology, technology, whatever. Imagine how much has changed, and then try to imagine how much will change 100 years from now. And I mean, if you can imagine it, then I say go out and try to make it happen.
I'm looking forward for a future where there's going to be billions more people for one reason in particular. That means that there's going to be billions more people that wake up in the morning trying to figure out and asking questions. Because knowledge used to be, limited to few. Now it's open to more, and we're trying, with STEM, we're opening the field to women and to minorities and to everyone. And in the future, just because of the numbers of it, more people asking questions can only lead for more discoveries and more fun stuff. Joel, it's been super fun. Thank you very much.
Thank you, Daniel. It really has been fun. I
Thank
appreciate
you.
this.
We'll make sure that we have all your contact information if people want to reach out in the comments. And
Please.
I know you're on
That'd be
LinkedIn
great.
and you're at the Institute, so everything will be there in the comment. In the meantime, keep asking questions. It's fabulous. And if anyone asks me why I went to Starmus, it's because of that. so take good care of yourself.
Thank you very much, Daniel. I enjoyed it very much.